For the introduction of radio astronomy is the study of celestial objects at radio frequency. When Carl Jansky of Bell Telephone Laboratories reported radiation from the Milky Way in 1933, it was the first time that the radio wave had been detected from an astronomical object. Observations made later that have revealed several distinct sources of radio emissions. This comprises stars and galaxies, as well as quasars and masses. Radio astronomy was used to find the cosmic microwave background radiation, which is thought to support the Big Bang idea. Large radio antenna, known as radio telescope, are employed in radio astronomy. These telescopes can be utilized alone or in conjunction with other linked telescopes by employing the methods of aperture synthesis and radio interferometry. Since an interferometer's revolving power is determined by the distance between its components rather than their sizes, radio astronomy can attain great angular resolution through the use of interferometry.
We move to the next slide, which is techniques and observation in radio astronomy. Firstly, we have polarimetry, measuring magnetic fields. Analyze radio wave polarization to infer magnetic field strength and orientation around objects like pulsar. Secondly, timing observation, monitoring time variable phenomena. Tracks timing of radio pulses from pulsar to study their dynamics and test gravitational. Lastly, radio imaging, creating visual representation. Combines data to create visual maps of radio sources using algorithms like CLEAN to enhance image clarity.
My name is Anna Suziana Binti Abu Bakar. My student ID is 2022663076. Today I'm going to present about benefit of radio astronomy. Radio astronomy has some advantage over optical telescope, which is they can work at any time of day or night, rain or shine. Close range and snow do not interfere with the viewing of a radio telescope in the same way that they do with optical telescope. Number one is a weather. Radio astronomy can be done from the ground without being greatly impaired by the weather, although the quality of the observation improves with a good weather. However, this is no radio antenna in space, which improves the resolution of the observation. Number two is a day and night. Radio telescope observes both day and night, but the sun has a detrimental effect on some observation. Number three is no absorption. Radio waves are not affected by absorption, which is optical waves are absorbed by dust clouds that are floating between the stars like a sort of interstellar fog. Radio telescopes see straight through the dust clouds. And lastly is hydrogen. Hydrogen accounts for approximately 90% of all observed matter in the universe, which is we have a wavelength 21.106114 centimeter. With the radio telescope, we can investigate the most abundant element in the universe.
Next is the disadvantages of radio astronomy. The first problem is revolution. On the negative side, to get good quality image that show all the details of the celestial object, it is more complicated than ENG at optical wavelength. This has to do with the long wavelength of radio wave. To get good angular resolution, they require large telescope. Next, the second one is complicated procedure. A complicated procedure is required to produce the image of the observer object. In other words, the observer does not see the image straight away. This procedure uses very powerful computers and it is necessary because of the way the observations are done.
Moving on to the uses, radio astronomy is crucial for various reasons. It aids in tracking and communicating with spacecraft on missions by using radio telescopes to send comets and receive data when they are far from Earth. Additionally, it helps in predicting solar activity such as solar flares and coronal mass ejections, which can impact satellites, GPS systems, and power grids. Furthermore, radio astronomy allows for the study of planetary systems, including their atmospheres, magnetic field, and formation processes, providing valuable insight into their potential for supporting life. Here are the visual examples of the uses of radio astronomy. The first one is a radio telescope, which is to communicate with the spacecraft. The second one is the prediction of solar activities, such as solar flares. And the third one is the study about a magnetic field.
From what other members have explained, we can conclude that radio astronomy is the study of celestial objects and phenomena via radio waves. It offers a unique view of the universe, revealing hidden phenomena, and assisting us in solving cosmic mysteries. Radio astronomy continues to uncover cosmic mysteries, providing a complementary perspective to optical and other observation.
Shine.